You can hear. You can hear. 100% infield. Huge thing here. This is also an island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm tube. Whoa. Be mine. All our different materials. How do you guys like this? we are live. Hello, how's everyone? Who do we have here? Traxman, Incendium, thank you for joining. Peslis, Enestio, talking about stepper motor today. Yes, or at least I will learn about it. Because to be honest, we did the same stream with the nozzle. I was a little bit more familiar, but stepper motors, I don't know anything. So we're gonna go from scratch. Makers Bees, Spoken True, Pete Savas, Jedi Spidey. Who else do we have? Non-Fam as well, and Come Out and PLA. Thank you everyone for joining. Let me quickly start the giveaway so that's out of the way. There, we don't need to think about it anymore. This, I'm awesome, and there you go. And then let me put the banner. There you go. So this is done, and then let me put this. Okay, great. So how's everyone? The electricity was out in Montreal for several hours today, and it's not completely stable yet. Oh, really? Because of what? Because of weather, hurricane, this kind of thing? Hey, Humble John, Just Mecca, how is everything? Bidersmark, thank you again for the help yesterday. For what? Oh, the Pastor Rimbo? Yeah, we already, I think it's shipped already. I need to check. I have the tracking number. But I think, yeah, I need to check. Hopefully it's going to arrive quick. Actually, we could have done it quicker, but our warehouse is really, really busy because we just finished the system change. So we have 3 weeks of back order to go through. So but we tried our best to go as fast as we could. I think it's still faster than getting it from Canada anyway. Stephen Poole, how are you? Timing work tonight, though, to keep streaming schedule in mind. On vacation for another week yet. Oh, you're on vacation? It's the 4th of July thing, right? I didn't know it was a whole vacation. I thought it was only one day off. But I guess some people take a couple of days, maybe. They take like a week for the 4th of July, something like this. Zombie, where is LDO Motors Jason when yeah, maybe he will be his knowledge will be very welcome maybe today. So let's see. To be honest, I just so you know how much I know about stepper motors. For me, there's only one type. I don't even know where to start, how to organize this. So, but anyway, we'll figure it out together. There's a lot of smart people in the chat, so we'll just put things together, right? Put our brain together. ADD Engineer has some awesome videos about stepper motors. Great. We'll have a look then. Heat wave, 30 degree. 30 degrees C is a heat wave? Really? Okay. 30 degrees like is when we go out here. Like when it's 30 degrees, then it's finally a good temperature, and then we go and play football, blah blah. Because when it's like 38, 40 degrees, then we stay at home with the AC. But it's interesting to know that 30 degrees is considered as a heat wave in Canada. Must not be very hot in average. Kedu Kevin, good morning. Pete Savas, you are the epitome of awesome for loyalty. Epitome. Okay, that's a new vocabulary. Epitome or epitome? Epitome. A person or things that is a perfect example of a particular quality. Oh, thank you so much. I didn't know that word at the same time. So, epitome. Thank you for this compliment. I'm really hoping it's going to arrive on time. I sent 5 spool, so then if it failed again, then he has some backup just in case. Where was I? Here, just had a power spike earlier today. Ended up 1 or 2 printers to fail for some reason. The print shifted upon recovery. A power spike. Why you have all of this? Like Loyal has a power outage. You have power spike. Peslis have some power outage. I mean, what? Why? I thought US and Canada were like a developed country. I thought that didn't exist in developed country, like this type of thing like this. Because when I lived in Africa, then we had that pretty often, right? Like every week, and then everyone has how do you call that? Um, how do you call that? You know, like the motor that you put outside, and then is if there is no more electricity, then you have that thing that use gas. I know the word in French, but anyway, it's like a backup. It's not a battery. It's creating energy. Anyway, we all have this, but in France here, I mean, I wouldn't even think that the energy would just drop suddenly like this, right? So, or is that in very very specific areas where it's not very developed or something like this? I love steppers. Should be a fun stream. Yeah, I think so, Zombie. I think so. Thank you, DMAT, for joining. We don't have AC everywhere, so people turning theirs is on stress on the system. I think it was close to 40 when it happened. Oh, okay. So it's not okay. Yeah, maybe here, because here we use AC all the time. Because in winter, then we have to heat up, and then in summer, then we have to cool down, and then it's always all the time. So I guess maybe here is more used to. Maybe the system is more is better designed for that. Is because I run the grid. Yeah, we should all complain to Zombie. He's the one that designed the grid. He needs to have a better how do you say, like electricity dispatch. Generator. Yeah, there you go. Everyone in Africa has their or at least where I live, the generator outside. I'm surprised LM has power issue. He's off grid living. Yeah, off grid. Oh, so he has his own generator all the time. Then he need a backup of a backup. He need a backup generator for his generator. It's all Zombie's fault. He was watching his printer, not the power level. Yeah. He didn't set it properly. Lawyer's power is off grid. He had breaker strips, and his generator was disconnected. Then his battery bank ran out. Okay. We're having our July wave, 113 Fahrenheit. Let me check. 113 Fahrenheit to C. 45 degrees C. Okay, yeah, that's hot. That's hot. 45 degrees C. When we have 45 degrees C here, then we usually just stay at home. No AC equal die. We have an older grid, and it's going to take a long time to upgrade. Oh, okay. So yeah, maybe. Okay, got it. Hope you feel better soon, Zombie. Oh, you're sick? You're sick, Zombie? Thank you, Lawyer, on new OPS system, so that shouldn't happen again. It feels like we never had power issue until we started prints that took over 8 hours. Then the battery backups were a requirement. Yeah, that's true. Maybe now you notice more when there is a small power outage because your printer failed, basically. Because all the other how do you call that, appliance, electrical appliance you have at home, then if there's a small power outage, then it doesn't do anything, right? Because like the fridge, if it's small enough, then the fridge won't have any issue. Your microwave, this kind of your blender, blah, blah, blah. But the printer, if there is an issue, then oh, is there any printer that if there is a power outage, you will when the electricity come back, it will automatically resume? Because I know the power outage recovery, right? But you have to be there. Like you wake up in the morning, if the power outage happened after you go to sleep, right after, then you missed the whole night, right? And then you have to restart. But is there some printer that do that automatically? Like it knows when the electricity came back, and then it just resume. Does that exist, or maybe or not, or it doesn't? Thank you for being awesome, Jedem. Spidey is spoken true. 7.5 out of 8 hours and the power goes out just for a few minutes. Yeah, that kills it, right? Especially if you don't have the power outage recovery, right? I went outside. There's a crude power loss recovery, but it's not 100%. Lawyer would not have a problem if the power off resume had been activated. Oh, yeah. I remember that he said on stream as well. Power loss recovery, but like Zombie said, not 100%. Yes. Tesla Powerwall and a 25 kilowatt generator, so my power would have to go out for a few weeks. The Tesla Powerwall is a battery. What is the Tesla Powerwall? I know what it is. Like, it's the thing you put in your garage for your car. But is that a battery or is that a generator? So the power would have to go out. Yeah, I mean, if you have, theoretically, it's a battery. Okay, it's a battery. Theoretically, if you have a generator, then as long as you have gas, then you don't need electricity, right? Is that correct? Because you still say it has to go out for a few weeks. But let's say you get infinite supply of gas, like you just go back and forth to the gas station, then you can generate electricity all the time, right? Mine rests on natural gas. Okay. You need a buffer while generator kicks on for smaller system. Oh, okay. Oh, so the battery is just to make sure that the it smoothly goes from the public grid to your own. Okay, got it. Okay, cool. I have a whole house natural gas generator, work non-stop with power loss. Oh, by the way, here's a question for English people. How do you make the difference between gas and gas? Like, you know, in French, like gas, I know gas in English is the thing you put in the car, right? Like the the liquid stuff that you put in the car, right? But how about the gas, the thing you use for your stove? You know, the gas, like how do you make the difference? Is that both are called gasoline, there's propane. Oh, the other one is not called gas. Gasoline is for car, yeah? Oh, gas and natural gas. So natural gas is the gas that is vapor, and the gas is the gas that is liquid. Oh, liquid equal gasoline, stove equals natural gas, propane. Oh, okay. So it's both gas, but one is natural, one is not natural. And if you don't want to make the mistake, you call gasoline for the liquid and propane for the vapor. Okay. Yeah, Paisley is gas, essence in French. Essence et gaz, le gaz. But in English, then it's gas and natural gas, or what do you say? Yeah, gasoline and propane. Okay, got it. Gas, natural gas. Okay, so when you say natural gas, it means it's the vapor stuff. Okay, got it. I'll say context mostly. Yeah, I don't like when it's based on context because it's hard to learn. It's hard to learn when you learn a different language. Liquid dinosaur and rotting dinosaur fumes. There are even hydrogen car now. Yeah, I've been following this as well. I think l'essence is liquid, gas is vapor in Quebec. Yes, yeah, exactly. Paisley. That's the French way, right? French way. Okay, cool. Okay, let me get my PPT. Where's my PPT? Stream PPT. There you go. Okay, let me share. Maybe I will move you there. Think Live, thank you for being awesome. And then let me put my Twitch here. Sorry, I'm just moving things around because I will put the PPT on my main screen. No, wrong. There you go. Yeah, you can take advantage of this small break to be awesome. Don't forget to be awesome and to the giveaway. Okay, there we go. And then maybe I will remove this so that I don't share it by mistake. By the way, a kind reminder for the people in the Awesome Squad, don't forget Saturday. Don't forget the Saturday announcement. Don't forget, because we need your feedback. We need you. So for people in the Awesome Squad, don't forget Saturday, if you have time. Saturday. Okay, there we go. What's up tonight, David Pulliam? We're going to talk about stepper motors. So let me check. Where was our nozzle discussion? Here, that was our nozzle discussion. Okay, so now we're going to have a new slide, and it's going to be a stepper motor discussion. I still need to do a poster for this one, but yeah, I'll do it soon. Stranger 3D Things, you're tired? Falling asleep? What time on Saturday? I will have to put it in my calendar because I'm so busy. 10 a.m. Easter Standard Time. 10 a.m. Easter Standard Time. Just need an unlimited power source and a ton of boron. Most efficient and greenest aware of technology. Okay, great. So, how to even start? How to even start this? So, just so we agree, what a stepper motor is. Let me just take. I will just start from my knowledge. It's gonna be very quick, and then you guys can jump in and try to. Okay, so here, so for me, okay, this is a stepper motor. Okay, this is a stepper motor, and then how to define stepper motors, like all the thing, like the characteristic of a stepper motor. So let's go just inside one stepper motors and see different characteristic, right? Okay, so I guess why it's called a stepper motors, from my understanding, it's called a stepper motors because there is basically the couple of magnets around, and then the magnets go on and off, and then it basically, and that's the step, right? So if this one goes off, this one goes on, then you go to the next one, this one goes off, this one goes on, then you go to this one, and then you have a couple of steps, right? So, but I know also that there is something that is called how do you call that again? Micro step or mini step, or I think it's micro step, and then you are in between. You are in between the magnet, right? So for example, this stepper motors, right, is a step angle 1.8 degree. Okay, so there is something that is called step angle, right? Micro step. Okay, there you go, micro step. What is this link, Zombie? Let me check. There we go. I click on full spec sheets. Okay, full specs. Click on full spec sheet. Full spec sheet. Okay, there you go. Okay. Okay. Okay, so there is something that is called phase as well. Step angle. Okay, so that's what we talked about. Okay, and let me at the same time just make sure that I have an understanding of what is inside. Okay, so this is okay. So this is exactly how I picture it. So I hope it's as easy as this, the simplification. And if I understand well, basically, all of these coil, they play around by going on and off, and that makes the thing in the middle, which I'm not sure, it might also be a magnet. The one in the middle, it makes it move, right? Because of these, because of this. Okay. So working principle, maybe we can go and check. Yeah, there you go. There you go. So I guess this roughly how, oh, okay. So it is a magnet. The one in the middle is a magnet that has south and north and south and north and south and north. Okay. Blah blah. Okay. So I think for from this point of view, we all have the same understanding, right? So now the question is, oh, there you go. Two-phase starter motor and three-phase. Okay, so this is what phase mean. Phase means how many of these the starter is part of the blah blah blah. Because here it says two-phase, right? So what does the question is, what does two phases mean? And here they just say this is two-phase, this is three-phase. But this is also two-phase. So it's not about the number of coil. I think it's the number of the one that can be different, I guess. So for example, here the red one will all have the same current and intensity, and the blue one will all have the same current and intensity. But in the three-phase, you can have three different current and intensity, I guess. That's how I understand it. Two-phase, single pole pair starter, left, okay, and two-phase dipole pair starter, right. The letter shows the magnetic field generated when positive voltage is applied between A plus and A minus. Okay. I skipped motors in college. Yeah, well, I skipped it also. Well, I didn't even have it. Okay, actually, this is pretty cool. Stepper motor basics, type, use, and working principle. Okay, so you know what? Let's just use this one to understand how it works. So, like I said, my knowledge is pretty much non-existent. So, if you guys know already how stepper motors works, then maybe this stream will be a tiny bit boring for you. But I will go from scratch because I really don't know, exactly how things works. But anyway, in this article, we'll cover the basic of stepper motors. So I guess that's the perfect. A stepper motor is an electric motor whose main features is that its shaft rotate by performing steps. Okay, so that's the name, stepper motor. That is by moving by a fixed amount of degree. This feature is obtained thanks to the internal structure of the motor and allows to know the exact angular position of the shaft by simply counting how many steps has been performed with no need for a sensor. Okay, and I think that's the difference between a stepper motor and a servo motor. I think the servo motors know all the time, know where it is, right? Even if you mess around with it, you will still know where it is. But a stepper motor, it can only count the step from 0, right? So if you mess up in between, then he doesn't know, you mess up the counting, right? But so I think that's one of the difference. This feature also makes it fit for a wide range of application. Okay, as all with electric motors, stepper motors have a stationary part. Okay, the starter. Okay, the stationary part, and the moving part, the rotor. Okay, on the starter, there are teeth on which coils are wired, while the rotor is either a permanent magnet or a variable reluctant iron core. Okay, I don't know what that is, but hopefully most of them is a permanent magnet, so that we don't need to understand what is this. And a permanent magnet, yeah, pretty straightforward, I guess. We will dive deeper into the different rotor structure. Figure 1 shows a drawing representing section of the motor. Okay, so far so good, right? A servo is a stepper motor with a tracker. Yeah, okay, got it. This is going to be a long dive starting on the high platform. Yeah, I mean, I need to understand it, and I like to go from scratch to understand, right? Hey, Mekomis, right? Do you want me to join you to explain models? Let me try. Let me try to study. Let me try to study first, and then at the end, if we have some question, then yeah, maybe that would be welcome. Actually, what we're trying to do, just so you guys are on the same level. Oh, thank you for the shout out. The 3 even I didn't see. Sorry, it's on the left there. Yeah, so we are trying to organize the knowledge of stepper motors, so that and vulgarize the knowledge, and then putting in a nice poster, the same way we did the nozzle. And but in order to do science vulgarization, you need to have a pretty good understanding of what it is. The only way of doing vulgarization is to know, is that an English word? I hope it is, right? Because I'm just using the French word and putting an English accent. Vulgarization. The act of rendering something coarse and refined. Degradation. Yeah, I hope you guys know what I mean when I say it's basically explaining science in a kid way. That's what it is. Hey, Westery, the first one in the world that made a workable 3D printed bow. Okay, great. Thank you for being awesome, Nightcore, Captain Bear 91. Okay, let's continue. So the basic working principle of a stepper motor is the following. By energizing one or more of the startup phase, a magnetic field is generated by the current flowing in the coil, and the rotor aligns with this field. Okay, so far so good. So this I know, when you have a coil and you put a certain current inside, it will create a magnetic field, right? And I guess, yeah, and then when you create a certain magnetic field, then you attract the permanent magnet. So far so good. By supplying different phases in sequence, the rotor can be rotated by a specific amount to reach the desired final position. Okay, so this is the part I never really understood about stepper motors. Like, let's say it's oh, well, now I understand. Okay, no, just forget. Now I understand. So basically it's here, and then this one will switch off, this one will switch on, and then it will be attracted by this one. And then, yeah, so, okay, no, I understand. Representation working principle. At the beginning, coil A is energized, and the rotor is aligned with the magnetic field it produces, okay, the A. When the coil B is energized, the rotor rotates clockwise by 60 degrees, okay, because you divide everything by 1, 2, 3, 4, 5, 6, okay, and 6 times 6, 36, right, the 360. The same happen when coil Z is energized. Okay, so far so good, no problem. Hey, Numeric, I would take one step back and go over what phases of electrical current does. I think you missed that. When we will arrive to the phase, I think is lower in the article. Then we will check what's the phases of electrical current, because I think I kind of know, I believe is like, you know, it's like this, right? You have the sinusoid, and then you have 3 different phases. One like this, one the same one but a bit after, and the same one but a bit after, or something like this. But yeah, we'll definitely check that. Just take baby step in learning about stepper motors. Yeah, that's what we're doing, Numeric. All in the cosplay, B, and really stress testing. Okay, great. Stepper motor type and construction. The performance of a stepper motor, both in terms of resolution, step size, speed, and torque, is influenced by the construction detail. My guess is the resolution will come from how many teeth you have. The speed will come from frequency, I think, or the quality of your wires, like how fast they can change. The resistance of the wire. My guess is the step size, the resolution will come from the number of teeth. The speed will come from how low the resistance of your system, like all the coils, and the torque will come from how much the wire can take the intensity. Okay, because I guess the torque will come from how strong the magnetic field is, and then that will come from how strong the electricity, whether it's the current or intensity. I don't know which one plays the most on making the magnetic field strong, but that's my guess. And that's a suggestion I give you. When you're learning something, try to always guess at the beginning, because you are trying to build the logic in your mind and then look at the answer, because I think that's a good practice. Is influenced by construction data, which at the same time may also affect how the motor can be controlled. As a matter of fact, not all stepper motors have the same internal structure, as there are different rotor and starter configuration. Okay, so that's what we're trying to do. We're trying to organize the different stepper motors. You know, how to classify the different stepper motor. So when it comes to the rotor, so the rotor, I think, is the thing in the middle here. There are basically three types of rotor. The permanent magnet. By the way, this is something we are not going to get in the article. If there is any of you that have the knowledge of what are in 3D printing, is there a particular rotor that is a standard, like most of them has this, or it really depends on the printer? So if you have that knowledge, feel free to share it in the chat. If you know what rotor is usually used in 3D printing, or it's highly depend, because it will also this knowledge organization structure will be for 3D printing, and there is no need to dive into something that 3D printing doesn't use, right? So okay, zombies say hybrid. So if most of the 3D printer use hybrid, then we'll just focus on hybrid, right? We won't focus on the other one. So, but I see there is a question mark. So maybe if some other could confirm hybrid. Okay. So maybe we'll focus on hybrid. But anyway, let's check the other one. So there is the permanent magnet rotor. The rotor is a permanent magnet that aligns with the specific field generated by the starter circuit. This solution guarantees a good torque and also a detent torque. Okay, so I have no idea what detent means. What does detent torque means? Detent torque is the torque present in the unenergized state due to the interaction of the permanent magnet and the starter teeth. Oh, so that's the thing. The detent torque is important when you're using belt system for the Z-axis. So if you're using belt system for the Z-axis and your detent torque is high, then you don't need anything when the electricity is out, right? But if you don't have a good detent torque, then when the electricity is out, then poof, your Z-axis is smashing in the bed. Okay, that's interesting. But that's for permanent magnet. Maybe the hybrid magnet, I don't know, doesn't have a very good detent torque, but apparently this is a good solution for good torque. So if you want a pretty strong printer, then it seems that permanent magnet is a good solution. This means the motor will resist, even not very strongly, to change position regardless of whether the coil is energized. Okay. Oh, and I think you can feel that. I don't have a stepper motor here, but I mean on the printer, but I think you can feel when you can feel the step when you're trying to spin the rotor. The drawbacks of this solution is that it has a lower speed and a lower resolution compared to other type. Okay, so good torque, good detent torque, but bad resolution and bad speed. Okay, so maybe that's the reason why we don't use that in 3D printing, because we need resolution and speed, but we might not be very interested in torque. in 3D printing. So maybe that's the reason why we don't use that. Okay, the other one is variable reluctance rotor. The rotor is made of an iron core and has a specific shape that allows it to align with the magnetic field. With this solution, it is easier to reach a higher speed and resolution, but the torque it develops is often lower and it has no detent torque. Okay, so the iron core, I guess, is already magnetized, and then you have a south pole and a north pole that are placed this way. Oh, okay, and then you have a north and south, a north and south, and a north and south. Okay, then they are placed like this, right? And then it allows you to have a dipole in every direction, or in this case, in 60-degree direction. Okay, that makes sense. Okay, and I guess the hybrid is a mix of both. Okay, so that could be pretty cool for 3D printing, right? Very high speed, high resolution. But maybe if it doesn't have a lot of torque, maybe that's not good in a way that you won't be able to have a high jerk on the the derivative of the acceleration on your printer, because when it will change direction, then if your stepper motor doesn't have a very good torque, then it will just skip when you have that whole inertia that goes on one side. So maybe that's the reason why it's not used. And finally, the hybrid rotor. This kind of rotor has a specific construction and is a hybrid between permanent magnet and variable reluctance versions. The rotor has two caps with alternative teeth and is magnetized axially. This configuration allows the motor to have the advantage of both the permanent magnet and the variable reluctance version. Specifically, high resolution, speed, and torque. Okay, so basically the hybrid has everything. So I guess that's why we use. So maybe my guess is the hybrid is much more expensive. So you can get everything, but you have to pay the price for it. And maybe if you only need torque or only need resolution, then you might be able to go cheaper and go for the other one, maybe. The higher performance requires a more complex construction and therefore a higher cost. Okay, there you go. Figure 3 shows a simplified example of the structure of this motor when coil A is energized. Figure 3. Figure 1 and 2. Wait, what? Figure 1 and 2. Which one was the hybrid? Maybe they don't show a hybrid. The tooth end. Figure 3 shows a simplified example of the structure of this motor. Figure 3. This is figure 3. Permanent magnet. Yeah, I think this is a bit strange. At the same time, due to the rotor structure, the S magnetized tooth align with the N magnetized tooth of the starter. Real motor have more complex structure with a high number of teeth, one showing the printer, though the working principle is the same. Okay, how does the hybrid motor look like? So it's kind of this mixed with this, right? So, but there's no particular picture. But stepper motor. Yeah, I guess it's some type of yeah, maybe it's not easy to represent. Maybe that's the reason. Not easy. Hybrid stepper motor basics. Yeah, so they use similar one, I guess. Oh, they all use this one. So maybe this is the hybrid one. It's a permanent magnet with an iron core. I don't know, but anyway, I think that's maybe not easy to represent. Okay, I think so far I think it's pretty clear. Hybrid. My motor have low torque. Cogging. What is cogging, Scott? My own personal motor has no torque. I tried cogging once, but I'm not coordinated enough. What is cogging? Cogging. Cogging torque. Cogging torque of electrical motor is the torque due to interaction between the permanent magnet of the rotor and the stator slot of permanent. Oh, that was the detent torque, right? What's the difference between cogging? Difference. Cogging vs detent. Cogging torque and detent torque refer to the same phenomenon. Oh, it's the same. Okay, got it. Okay, it's the same. Okay, so I think it's clear. I don't think I missed much. Do you mean 4? It's image 4. There is no image for the second type. Oh. The rotor is made of an iron core, has specific shape that allows to align with the magnetic field. Figure 1, figure 2. Figure 1, figure 2. Figure 1, figure 2. Oh, okay. I got it. So let me think. Oh, okay. Sorry. Like Zombie just highlighted. So sorry. The permanent magnet rotor is this. Okay, so it's circular, and then there's different pole. Okay, south, north. Okay, and this is a permanent magnet. And then the variable reluctance rotor is just iron. So this is just iron, but it just play on the shape. So you see, this is a plus shape, and it plays on the shape in order to when there is an electromagnetic field, then it will just align because of the shape. Okay, so in this case, it aligns here, and then when this one off and this one on, then it will align. But why does it align this one and not this one? Because this one is much closer to this one than this one is. So actually, it should go the other way, right? But anyway, maybe the arrow has changed. But yeah, okay, so I understand. And then the mix of both is you use that shape, and at the same time, both of them are permanent magnet. And then you use it. Oh, okay. Got it. I missed that. Thank you, Zombie. I missed that. So, okay, very clear. So this is what we use in 3D printing. This thing here. And it has good resolution, good speed, good torque. But it is expensive. Cogging is the resistance you feel when turning the motor. Okay. So that's the for some reason they call this also detent. Here, detent torque. They also call this detent torque. So cogging and detent torque. Okay, got it. Okay, next is the stator. Just making sure. Thank you for being awesome, Sheldon from 2020. The stator is the part of the rotor responsible for creating the magnetic field with which the rotor is going to align. Okay, so it's the thing with the teeth. The main characteristic of the stator circuit includes its number of phase and pole pairs, as well as the wire configuration. Oh, so pole pairs meaning you can only have an even number of teeth, I guess, because they have to pair with each other. So you can only have an even number of. So it's not about. So that's why they don't say the number of teeth, but the number of pole pairs, and then phases, which I guess is what we are going to discover, as well as the wire configuration. The number of phases is the number of independent coils, while the number of pole pairs indicates how many pairs of teeth are occupied by each phase. 2-phase stepper motors are the most commonly used, while 3-phase and 5-phase motors are less common. Okay, so for example, I bought a press, an oil press for my island business, and this is a 3-phase, and but I cannot plug it. I cannot plug it to the regular wall thing, because I think our wall plug is a 2-phase. So I need a special plug for this 3-phase. So I think in 3D printing, I guess we don't use the 3-phase, because otherwise we would have to plug it to a special plug, I guess. And 5-phase, I've never heard this one, but I guess you need another plug. Yeah, you need a phase generator. So what we did is we have a, is that the transformer or the converter? I think it's called the converter, right? Is the phase generator a converter, or is that completely different? Power grid and motor phases are a bit different. Converter, right? Okay, yeah, converter. So I had to buy a converter for that press, but I'm losing a lot of energy when I use that converter. And that's something I know by experience. I don't know why I'm losing energy, but I know I'm losing energy when I go from 2-phase to 3-phase rather than having 3-phase directly. Power grid and motor phases are a bit different. Power grid and motor phases are a bit different. You're mixing concept. Oh, you mean my example of the 3-phase is different? Okay. Then just forget about my example. Just forget about it. Okay, so this is okay. So this has 2 pole pairs. No, one. This one has 1 pole pairs, 2-phase. This one has 1 pole pair and 3-phase. 2-phase starter winding and 3-phase starter winding. Okay, and then what is this? And then this is a single pole pair 2-phase, right? And this is a 2 pole pair 1-phase, 2-phase. So 2-phase single pole, yeah, and dipole pair starter. The letter show the magnetic field generated, blah, blah, blah. Okay. So good. So far, so good. Okay. So maybe, for example, here. Okay, so now we start to understand a little bit more these spec sheets, right? Phase number 2-phase. Okay, so that means there is I don't know what is this, but so there is only 2 independent pair of coil. Detent torque, okay, so cogging torque or detent torque is how much it can resist when the electricity is out, when there is no electricity, right? And the rest we don't understand yet. We don't understand. I'm pretty sure step angle will come from how many pole pair there is, but let's continue our learning, and then we'll start to understand the spec sheets a little bit more. They use about 80% more energy running through the phase converter. Same name, different thing. Again, gas. Yeah. Yeah. Okay. So maybe that's the reason. Okay. Stepper motor control. We have seen previously that the motor coils need to be energized in a specific sequence to generate the magnetic field with which the rotor is going to align. Several devices are used to supply the necessary voltage to the coil and thus allow the motor to function properly. Starting from the device that are closer to the motor, we have a transistor bridge is the device physically controlling the electrical connection of the motor coils. Okay, transistor can be seen as electrically controlled interrupter, which when closed allow the connection of the coil to the electrical supply and thus the flow of the current. 1 transistor bridge is needed for each motor phase. Okay. So the first one is basically an electrical switch for each phase. So for a 2-phase, you will have 2 transistors. Okay, and basically we will electrically switch on and off these different phase. Okay, so 2 transistors to make it easy. 2-phase, 1 transistor per phase. A pre-driver, so this is the closest to the motor, and then before the transistor. A pre-driver is a device that controls the activation of the transistor, providing the required voltage and current. It is in turn controlled by a MCU. Something computer unit? MCU. Yeah, maybe not that MCU. MCU chip, I guess. Micro. Why is MCU microcontroller? What's the relationship? MCU. MCU, what does MCU stand for? Stand for microcontroller unit. Okay, microcontroller. It's an acronym, microcontroller unit. Okay, so you have microcontroller units. Okay, pre-driver device. It is in turn controlled by an MCU. So you have a pre-driver, and this pre-driver is controlled by a microcontroller unit. Okay, and this pre-driver controls the activation of the transistor, providing the required voltage and current. Okay, to switch them on and off. Okay, got it. Microcontroller, processor, master control unit, microcontroller or microcontroller. Okay, got it. Okay, and then an MCU is a microcontroller. The answer was literally in the next line. MCU is a microcontroller unit which is usually programmed by the motor user and generates specific signals for the pre-driver to obtain the desired motor behavior. Okay, so basically the MCU, that microcontroller is the one that will be connected to the printer board, I guess. And then the printer board is going to tell the MCU what he wants. The MCU will then relay that information to the pre-driver, and the pre-driver will take that information and give out switch on and off order to the transistor, and then the transistor will allow the electricity to go on and off, and then get what you need. Oh, can you imagine? How can we? I'm so impressed by how we arrive at this point, right? We like the evolution to arrive at something so complicated. It's it's crazy. Thank you for being awesome, Franken Gaming. An Arduino Uno, an H-bridge motor controller, and the stepper. What is that? Oh, you mean so the MCU could be an Arduino, the pre-driver could be a H-bridge controller, and then you have the stepper. Okay. Okay. Stepper motor driver types. Okay, what was the driver already? So all of these, all the three things are, driver here, driver. Okay, so the driver is the pre-driver and the transistor. Okay, so the driver is the thing in between the MCU and the coils. Okay, and there is different type of driver. Okay, so the driver doesn't include the MCU. The driver is these two first here, the transistor bridge and the pre-driver. Okay, so stepper motor driver types. There are different stepper motor drivers available on the market, which showcase different features for specific applications. The most important characteristic includes the input interface. The most common options are step direction. By sending a pulse on the step pin, the driver changes its output such that the motor will perform a step. The direction in which is determined by the level on the direction pin. Okay. So you have different way of driving a stepper motor. You either do a step direction. So you either give an information about one step and in which direction, and then you just give him as much pulse as you want steps and in which direction. So it's step and direction. Another way to communicate with the driver is phase and enable. For each starter winding phase determines the current direction and triggers enable if the phase is energized. Okay, I will have to understand this one. Phase enable. For each starter winding phase determines the current direction and triggers enable if the phase is energized. So the current direction, phase determines the current direction. Okay, so it will mean the direction. So the current direction is also, you know, in which in clockwise or counterclockwise. And triggers enable if the phase is energized. Yeah, I don't understand the second type, how the second type work. For each starter winding phase, okay? Phase. So you have one input that is phase, one input that is enable. The phase will determine the current direction. And the enable is and trigger enable if the phase is energized. Oh, this one I don't this one I don't understand. This one was pretty easy. You just you have a step pin and you have a direction pin. Very easy. Step pin, direction pin. I hope we all use this one. Okay, let me check the third one. The PWM directly controls the gate signal of the low side and high side FET. What is FET? The more I go into that, and the more, okay, let me just check what FET means. FET, what does FET means? Thank you for being awesome, Veronica. Okay, my internet is a little bit low. Okay, FET. Field FO, that's the transistor. Oh, the transistor. Okay, got it. Directly control the gate signals of the low side and high side of the transistor. Okay, so PWM will directly control the transistors. So it kind of make the pre-driver a bit useless, right? The gate signal of the low side and high side of FET. Okay. So there's only the second one that I don't understand completely. And okay, so out of your knowledge, do you know the one we are using in 3D printing the most? Because I think I've seen this PWM already. I think I've seen that. So maybe we're using that. Okay, so let me check here. Is there any information about that? It's the motor driver type. So is there something related the driver type? Phase number, rate, induction, phase, insulation, weight, inertia, high pot, rotate direction, holding torque, resistance, rated volt, no. Label by laser print, diagram. Let me check. Maybe no. Or maybe it's this kind of pin here that is kind of give it away what type it is. Or maybe all the stepper motors are all the type, and then you just choose. Maybe you just choose how you wanna. Yeah, maybe not. Okay, let me see. Let me go a little bit deeper there. Stepper motor driver, current regulation, flexible, blah blah blah. Woo. Dual edge bridge driver, blah blah. Okay, there is some names here. Sorry, PH blah blah 06 AWJ. Nope. I don't know. Phase enable HSL. So this is PWM. This is a PWM. This is a phase enable, and it doesn't seem to have much step and direction one. Integration offset. Okay. FDAF step direction. Oh, it's step. How do you know this is step direction? Where is that written? Major Gamer Geek, thank you for being awesome. Daddy Wazzy, thank you for being awesome. Kevin Tucker as well. Where the stepper driver comes in. The stepper driver is this. You have the microcontroller, and then the microcontroller is going to give order to the pre-driver. The pre-driver is going to switch on and off the different transistor. And this pre-driver with the transistor, that's called the driver. And then this driver will drive the different coil, the different coil in the stepper. So the driver is in between. Stepper is independent of driver type. Oh, so you mean, so this is only the coil stuff? This is only the coil? There is nothing inside? Oh, then I misunderstood. I thought all of this was in the stepper motor. Oh, my bad. Okay, so a stepper motor is basically, so these pins are is directly linked to the coil. There is nothing else inside. There is no PCB inside. No, the driver is the stepper driver on the MCU. Okay, so just to confirm, when you say no, it means like, so there is no PCB inside there, right? So just to make sure. No, the driver is the stepper driver on the MCU. Yeah, but the MCU is not there, right? Just to make sure. It's not in the okay. So it's not inside. Coils and magnets only in house. Oh, okay. Oh, okay. I got it. So that means these pins, just to make sure, if you can confirm, these pins are directly it goes directly to the coil. There's nothing in between. Like, it's the coil, and then the end of the coil will be linked to the pin. Okay, so if there is 1, 2, so this is a 3, but then that means this is a 3-phase motor, right? Because there is 3 pairs of pin, 1, 2, 3, 4, 5, 6. So does that mean there is 2 pins that are useless? No PCB in the motor. Okay. So does that mean there is two useless pin here? Because there is 2 pair of coil. So there's only 2 pair that is coming out, right? Then what's the or are something built into the CPU itself? Usually those pins are open. What does open means? Means is useless, right? Means there is 2 pin, maybe 5 and 6. No pin in 2. Oh, I just saw it. Okay. So 2 and 5 are useless. 1 goes to C, 1 goes to A, 3 to C, 4 to B, 6 to D. And then C is linked to A, and B is linked to D. So the pair, you have BD, the 6, and the AC, the 1. So the 2 and 5 are fake pin, right? The 2 and 5 are, I don't even know why we have them. Maybe for manufacturing to make it cheap, because they produce the 2-phase and the 3-phase at the same time, and they just use the same component. But then when it's a 2-phase, then you have 2 of them that are useless. I have opened stepper motor before to solder and replace the JST plug. Don't know what is this. Some steppers have a wire that goes to the center of each coil. Some steppers have a wire that goes to the center of each coil. Okay. But not useless, sometimes used for additional control. Yeah, but that's the thing I don't understand. What's the additional control? What? So in this case, just to make it easy, in this case, they are useless, right? A, B, C, D, A, clockwise. Okay, so
I guess they are useless. I guess. Let's just say they are useless to make it easy for today. um, okay. Okay. So that means okay. So the driver is okay on the printer board. Okay. Okay, but that still doesn't. Well, I kind of okay. So that means the P. So what type of driver do we usually use in 3D printing? I think FDAFPatch was saying step direction. So let me check. Let's go 3D printing, 3D printer, stepper motor driver. Okay, let's go and check that. Okay, let's go and buy a driver. Let's go and see. Maybe we will understand a little bit more. Okay, so for example, this driver. Okay, let's go here. Let's try to see this driver, which type it is: step direction, phase enable, or PWM. Okay, so we have this driver. Step 6, stepper motor driver module, heatsink, 3D printer riprap, blah blah blah. Okay, is there some type of specs? Product description: low RDS output, automatic blah, internal mix with slow current decay mode, synchronous rectification, blah, crossover, thermal shutdown, blah, compatible, thermal shutdown, ground faulty. Okay, it doesn't say much, right? So how do we know? Why is this? This should be an important information, right? To know what type it is, or is it? Maybe I should go to a website instead of going to. Oh, this is for Hobby Power. Maybe this is linking to what? Okay. Documentation. Okay. TMC. Okay. Compatible with step C, blah blah. TMC stepper motors driver are most common. Look at the diagram on the stepper datasheet. Diagram on the stepper datasheet. Here, and then the diagram. This one. I don't even know what. BGRB. Yeah, I have no idea. I have no idea what all of these are. I don't even know what is what. Those older steppers reminds me of when we were making 3D printers sing. Look at the diagram, blah, okay. Yeah, so what I'm trying to figure out, just to make sure we are all aligned, is what type. So this is different stepper motor driver types, and which type is the most used in 3D printing: step direction, phase enable, or PWM? Okay, that's wiring, black, green, red, and blue. Black, green, red, and blue. Oh, okay, wiring. And then LREL or KNDU. Yeah, anyway, so that's what I'm trying to answer first. Okay, so there is a link that was sent by Major Gamer Geek, and there is the word wiki inside, so it should be interesting. Open that. Read the pin on A4988. Read the pin. Sorry, I have many things open. A4988. Read the pin. Okay, so let me go back. Read the pin. Okay, so this is a TMC 2208. And then you have some pins, okay. It's an ultra quiet 2-phase. Okay, so this is for 2-phase stepper motor. Continuous drive, blah, blah, flexible microinterpolation, blah, blah, compatible, blah, blah, can replace. Okay, so again, what I'm looking for is this. From what I understand, you have 3 types of stepper motor driver. Which driver are we? So for example, this one, which type it is? Oh, step direction. Yeah, there you go. So, oh, okay, it's called interface. So the interface of this is step direction. Oh, got it. Okay. So, and this is used for 3D printer. Okay, so let's take another one, for example. Let's take this one. Okay, how about this one? Where is the interface? So this one, size, moves, heatsink. Is this a stepper? Is it a upgrade specially designed for high voltage drive requirement? Okay, so that's also a driver, and what type it is? Encoder interface, compatible with step in. Yeah, step direction interface. Okay, so they are all step direction. And let's go this one. And this one is direction step interface. Okay, so basically like FDAV say, right? We are mainly using in 3D printing. We are mainly using step direction. But why, for some reason, I saw PWM somewhere in 3D printing. Maybe some people are using this, maybe for custom one or something. But okay, so this is the one we usually use. So if you are looking for a stepper motor driver, then this is I don't know what are the pros and cons of each of them, but okay, very good. Here's a list of stepper driver you can find in the this constantly updated, blah blah. Okay, great. So let's continue. Read the P. Thank you, Alex. The answer was there. You just skimmed it. Fans, PWM. That exists also, right? PWM is used for heater and cooling fan. Oh, fans. I thought Scott was saying he's a fan of PWM, but he's actually saying the fans are using PWM. Okay, PWM is used for heater. Okay, the trolley rolls on the next stop. Driver drive the bus, and no fans, heater, lights use PWM. Okay, got it. I thought you say you are a fan of PWM. Okay. Anyway, I guess that's another word that depends on the context, right? Okay. Another important feature of a stepper motor driver is if it is only able to control the voltage across the winding and also the current flowing through it. Another important feature of a stepper motor driver is if it is only able to control the voltage across the winding or also the current flowing through it. Oh, okay. So the driver can control the voltage of the different winding, but some of them can also control the current that is flowing through it. With voltage control, the driver only regulates the voltage across the winding. The torque developed and the speed. Hey, this is what we guessed, right? The torque is linked to the voltage. The torque developed and the speed with which the steps are executed only depends on motor and load characteristics. Current control drivers are more advanced as they regulate the current flowing through the active coil in order to have better control over the torque produced and thus the dynamic behavior of the whole system. Okay, So now the recent driver, they are controlling both the voltage and the current for better control. Okay, got it. Cool. We use step direction because it's less processor intensive and good enough for a 3D printer. Phase enable is better for phase control, mainly for industrial use and specialized stepper like the one on professional CNC mills. PWM is almost never used, mainly for only speed control. Oh, okay, great summary, FDevPatch. Thank you. Actually, you know what? Let me copy paste that summary for our for here. I think it's a great summary for our cheat sheet, that we are creating. So let me put that here. Okay, and then let me Edge of 3D, and then let me put this from Edge of 3D as well, where the PWM is used in a printer. Okay, great. I usually skip the PC and go all in on the RGB, better ROI. Okay. Okay, great. Okay. Unipolar or bipolar motors. Another feature of the motors that also affect control is the arrangement of the starter coils that determine how the current direction is changed to achieve the motion of the rotor. It is necessary not only to energize the coil, but also to control the direction of the current, which determines the direction of the magnetic fields generated by the coil itself. Okay. In stepper motors, the issue of controlling the current direction is solved with two different approaches. Okay. So how do we change the current? In unipolar stepper motors, one of the leads is connected to the central point of the coil. This allows to control the direction of the current using relatively simple circuit and component. The central lead is connected to the input. Okay, so let me check the diagram at the same time. Okay, so this is the voltage that goes in. And okay, so one of the leads is connected to the central point of the coil. Okay, so this is the coil, and then the coil is, okay, you have this. Okay, so you have 1 and 2 here. And then you have V in. If the MOSFET 1 is active, so this is the MOSFET 1, the current flows from AM to A+. From AM, oh, you have 2 V in. You have a V in here as well. What is this V in doing here? Oh, is that what someone was saying this? Someone was saying that there is something that wire that goes in the middle of the coil. Maybe that's this V in here. Oh, so maybe it's not useless. Maybe the 2 and 5 are not used. Okay, let me just finish. So, or oh no, maybe these V in are the same. No, I don't know. Let me finish. If MOSFET 1 is active, so if this one is active, the current flows from AM, okay, AM to A+. Okay, so in that direction, and then it goes here and then exit here. So it goes from V in, then it goes here and then exit here. If MOSFET 2 is active, the current flows from AM to A-. So it goes this way. From V in to this, but then there is only half of the coil that is okay. Generating a magnetic field in the opposite direction. As pointed out above, this approach allows a simpler driving circuit. Only 2 semiconductors needed. but the drawback is that only half of the copper is used. Yeah, that's what I just said, right? Half of the copper is used at a time. This means that for the same current flowing in the coil, the magnetic field has half the intensity compared if all the copper were used. In addition, these motors are more difficult to construct since more leads have to be available as motor inputs. Okay, understood. So I have no idea why this V in. I guess this V in is not useful, but this V in. Okay. So understood. So this is unipolar stepper motors, and this is bipolar stepper motors. V in is voltage ins, yeah. Step 6 Pololu drivers are voltage control and still very popular. TMC silent drivers and current control and not often used in low-cost machine. V-in is the same, yeah. Those are different steppers. The one you are reading is a unipolar steppers. The one of your data sheet is a bipolar one, but yes, the connector and manufacturing purpose is the same body. Yeah, okay. So this one is a bipolar stepper motor. Each coil has only 2 leads available. I don't know what leads mean, but I think is how many. Yeah, each coil has only 2 leads available. So this one has 3 leads. One of the leads is connected to the central point of the coil. Okay, so the leads is like how many points are connected to the coil. That's what they call a leads. And these only have 2 leads available. The other one has 3 leads. And to control the direction, it is necessary to use an H bridge, as shows figure 8, blah, blah, blah. If MOSFET 1 and 4 are active, so 1 and 4, yeah, then it will go this way, right? You go from A plus to A minus, yeah, okay. And if 2 and 3, so if 2 and 3, then you will go from A minus to A plus, right? Yeah, A minus to A plus, generating a magnetic field in the opposite direction. This solution requires a more complex driving circuit, but allows the motor to achieve maximum torque for the amount of copper that is used. Okay, so with technology progress, the advantage of unipolar are becoming less relevant, and bipolar stepper are currently the most popular. Okay, so bipolar stepper. So how do we know this is unipolar or bipolar? Is there, or is it unipolar is so outdated that we don't even mention that is whether it's unipolar or bipolar? It's definitely, all of them are bipolar. I guess so, because I don't think they say much. Yeah, no. Or you can choose. Maybe unipolar. Let me think. This diagram is in the stepper or is? Let me think. No. Actually, this is the driver, so it's not in the stepper. So the stepper cannot be unipolar or bipolar. The stepper is we don't care. The stepper is we don't care, right? It's the driver. Let me think. No, but because the wiring is different. Oh, so maybe that's the reason why there is the additional pin here. If you want to use it with a unipolar driver, then you don't need this pin here. Maybe this pin goes to the middle of each coil. And if you want to use, oh, okay. So maybe these two pin goes to the middle of the coil. And then if you want to use it in a unipolar way, then you have to use the middle pin. And if you want to use it in a bipolar way, then you have to use this pin. So the stepper motor can accept both, depending on how it's constructed, right? Oh. Unipolar can be driven bipolar, but not the reverse. 2 and 5 are not used. Thank you, Maccabee. Slowly understanding everything, right? Okay, so let me catch up a little bit. Thank you for being awesome, Derek. Lead equal wire and pin. Okay, got it. Thank you for being awesome, King Hats. Diagram shows 2 lead side. Okay. Look at the diagram, the thing with the word diagram on top, and compare with the article you're reading. Look at the diagram. Oh, this is the diagram. Black and green, red and blue. Oh, there you go. Okay, so in this particular one is the bipolar. And this bipolar cannot be, okay, now I understand. Cannot be used in unipolar because they don't have the 2 and the 5. Yeah, basically inexistent, basically. So AC, B, D. Okay, so the AC, and then is this one here. A plus, A minus, B plus. Okay, got it. Good. We're getting there. Okay, so we have a bipolar stepper motor here. Okay, and now black, green, red, blue, black, green, red, blue. Okay, everything starts to make sense. Okay, good. Okay, next. Hey, Sebastian, this is both left. Unipolar can be driven, 2 and 5 are not used. Yes. Thank you for being awesome, people. Lucifer, Collie, Alex. No diagram, no life. Okay, stepper motor driving technique. Okay, so there's different technique of driving a stepper motor. There are 4 different driving technique for a stepper motor. 2 and 5 are considered central tabs to the coil of each corresponding side. Yeah, but apparently in this case they are not used at all, right? They are not even in the diagram. Because if there would be a thing here, then you could drive it as a unipolar with a unipolar driver. But apparently this one no. But yeah, makes sense. Makes total sense. Okay, so one technique is the wave mode. Only one phase at a time is energized. Figure, okay, only wave weight at a time. Okay, so this is energized, then it aligned, then this is energized, then this is energized, this is energized. Blah, blah. For simplicity, we will say that the current is flowing in a positive direction if it's going from the plus lead to the minus lead of the phase. Okay, otherwise the direction is negative. Okay, so here plus to minus, so it's a positive. Plus to minus, plus to minus, positive, and this is negative. Okay. Otherwise the direction is negative. Starting from the left, the current is flowing only in phase A in the positive direction, so it's attracting the north direction. Is aligned with the magnetic field generated by it. In the next step, it flows only in phase B in the positive direction, so it's still attracting the north, 90-degree clockwise to align with the magnetic field generated by B. Later, phase A is generalized again, but the current flow is in negative direction. Okay, so then it's going to attract the south, here, the south. Okay, and then it makes a total spin. Okay, so this is wave mode. Sebastian, you can resolder some stepper motor like between bipolar and unipolar, but the NEMA, you don't have the tab in the coil. Okay. Hey, Sun Turtle. For example, for the Babybel printer, you're supposed to resolder. Is there any 3D printer that uses servo motor? There must be somewhere in the world. It must be. Thank you for being awesome, Kenneth Sang. Okay, so this is wave mode. The other way is full step mode. In full step mode, two phases are always energized at the same time. Figure 12 shows the different step. It's incredible. Sorry. The steps are similar to the wave mode ones, the most significant difference being that with this mode, the motor is able to produce a higher torque since the current is flowing in the motor and the stronger magnetic field is generated. Oh, okay. So in this way, it's the same, but we are not using the direct magnetic field. We are using the resulting magnetic field from both coils. So this one only one coil, so we just take the magnetic field of that coil. But when the two coils are generating a magnetic field, then it will align with the resulting magnetic field. But the resulting magnetic field is the addition of two magnetic fields. And my guess is that when you sum up magnetic field, then it's twice. There may be a factor issue, but I guess it's twice. I don't know if there is a square somewhere, but it's twice as strong. One magnetic field plus another magnetic field equal twice the amount of the magnetic field. In this case, it's not exactly twice because the magnetic field are not aligned, so the resulting has a little bit of a lower factor, but it's still higher than if it was only one. My guess is this one. Okay. Half-step mode is a combination of wave and full step mode. Using these combinations allow for the step size to be reduced by half. In this case, 45 degrees instead of 90 degrees. The only drawbacks is that the torque produced by the motor is not constant, since it is higher when both phases are energized and weaker when only one phase is energized. Okay, so in this case, we use both, right? We can do it like you go this way, and then we can do halfway, 45, and then 90, and then 45, 90, 45, 90, blah, blah, blah. But like they say, okay, the issue is when it's aligned at a 90 modulo, then you will have a lower torque than if it aligned at a 45 modulo. Okay, makes sense, makes sense. And the final one is called microstepping. Microstepping can be seen as a further enhancement of half-step mode. The half-step was what? This one, the half-step mode, okay. Because it allows to reduce even further the step size and to have a constant torque output. This is achieved by controlling the intensity of the current flowing in each phase. Okay. So that means you need a driver that is able to control intensity if you want to do microstepping. Oh, okay. So how do we know if... oh, no, it's about the driver. Not. So let's go and see our driver here. So if we go and see the driver, let's see if this driver can control intensity or not. Or maybe they all can control intensity. I don't know. Ultra continuous direct current, peak current, voltage range, continuous drive current, voltage current subdivision, flexible, blah, blah, blah. Okay, so how do we know if this driver can, because it has a voltage range, so it means it can control the voltage. But can it control the intensity? Because here to do microstepping, we need to control the intensity of the current flowing in each phase. So is this driver able to control the intensity? Microstep, okay, so it looks like it has microstep. So if it has microstep, I guess that means it can control intensity, right? I think so. Can it? Third feature. 1, 2, 3. Native microstep. So that's the one that allows you to say that the driver can control the intensity. So they don't even talk about intensity. They talk about microstep directly, right? So that's how defined they can control the intensity, right? And that's the microstep stuff. So if you have a good driver, it can control the intensity very, very accurately, and you have a better microstep. But if you don't have a good driver, then it cannot control the intensity very well, or something like this. So I guess something like this, right? Where was it? Not consumer grade 3D printer, blah blah. Hey, Ramolin, which is sort of servo hybrid, blah blah. You can calculate with vectorial algebra, yes. Total magnetic flux, yes. What are we doing? We are trying to understand stepper motors. That's what we're doing. Yes, of course, even the cheap drivers can do microstrapping. It's just PWM. But these are not PWM. These one are not PWM. These are step drive, which is step direction. Sorry. So these are not PWM. All the step stick could only do. Okay. So I guess if a driver is talking about microstepping, then it means it can control intensity. Maybe nowadays there is no driver that cannot do intensity, right? Yeah, but the output is PWM, not the control. The output is PWM, but PWM directly controls the gate signal of the low. But PWM is how can an output be PWM if it's a step direction type? Sorry, Sebastian, I don't understand what you're saying. Okay, so blah, blah, blah. Using this mode requires a more complex motor driver compared to the previous solution. Shows how microstrapping works. If Imax is the maximum current that can flow in a phase, starting from the left, in the first figure, IA get Imax, okay? And the next step, the current are controlled to achieve 92% of Imax, and IB is 38% of Imax. And then you will go this, which generate a magnetic field that is rotated by 22.5 clockwise compared to the previous one. This step is repeated with different current values to reach the 45, 67.5, and 90 position. This provides the ability to reduce by half the size of the step compared to the half-step mode. But it is possible to go even further. Using microscape stepping helps reaching very high position resolution. But this advantage comes at a cost of a more complex device to control the motor and a smaller torque generated with each step. Indeed, the torque is proportional to the sine of the angle between the stator magnetic field and the rotor magnetic field. Therefore, when the steps are smaller, the torque is smaller. This may lead to missing some step, meaning the rotor position does not change. Okay, so that means, because one thing I do understand is they see here, it allows to reduce further the step size and to have a constant torque output. But I don't think the torque is constant, right? Like the torque here, I think the torque here should be lower than the torque here. And they are saying this, right? They are saying the torque is proportional to the sine of the angle between the stator magnetic field and the rotor magnetic field. Yeah, so I think this part, I don't think this part is correct, right? To have a constant torque output. I don't think you can have a constant torque output wherever you are. either I don't understand, either this is a mistake. Like the torque is proportional and the torque is constant, then that doesn't go together for me. Let's better not dive on sinusoidal wave PWM generation. This has nothing to do with the step direction thing, which is the signal for the driver what to do. Microstepping is just turning on and off the coils very quickly. Output, not input. There you go again, saying PWM when you actually mean PWM. What? PWM pulses the voltage current to give a lower average volt current value in a mechanical device. Oh, so that's two different things. Sebastian is not talking of the interface, he's talking about the signal that the driver sends to the stepper coils. That is PWM, but is an internal process to generate a sinusoidal signal. Oh, you're talking about how to achieve the lower intensity, right? By switching on and off. Okay. You need more magnets, blah, blah, blah. Okay, cool. So, okay, so I think so far so good. Let me check. Yeah, okay. And yeah, whatever type it is, whether it's step direction, phase enable, or PMW, I think you can use all the technique, I guess you can use all the technique. Okay, so stepper motors, advantages and disadvantages. They are varying the volts and therefore magnetic flux, so at the full step. Now that we understand the working principle of the stepper motors, it is useful to summarize their pros and cons compared to other motor types. Advantage: due to their internal structure, stepper motors do not require a sensor to detect the motor position, since the motor moves by performing steps. By simply counting these steps, you can obtain the motor position at a given time. They only give enough to equal the flux at a single pole. Not following this one. You're talking about how to make the torque consistent and not proportional. In addition, stepper motor controls is very simple. The motor does need a driver, but does not need a complex calculation or turning or tuning to work properly. In general, the control effort is lower compared to other motors. With microstepping, you can reach high position accuracy up to approximately 0.007 degree. Stepper motors offer good torque at low speed, are great for holding position, and also tend to have a long lifespan. Okay, and the disadvantages: they can miss a step if the load torque is too high. This negatively impacts the control, since there are no way to know the real position of the motor. Using microstepping makes stepper motors even more likely to experience this issue. These motors always drain maximum current even when still, which makes efficiency worse and can cause overheating. Oh yeah, of course, because even if it doesn't move, then it maintains the position, so there is still a full current going through the coils. Stepper motors have low torque and become pretty noisy at high speed. Finally, stepper motors have actually what makes the noise? Is it the noise because they do a lot of small steps? Each step creates vibration, and this vibration controls noise. So the fact that it's not smooth, that's why it's noisy. Finally, stepper motors have low power intensity. Oh, so that means if you have a driver that can smoothly change the intensity instead of suddenly, then it makes the stepper motor quieter. So if you have a high quality driver, then the stepper motor will be quieter. Or if you have a stepper motor that is built properly, it doesn't vibrate too much, then it will be also quieter. So is that how you make something quiet? Yes, you are correct on the noise thing. Oh, okay, makes sense. Makes sense. Finally, stepper motors have low power density and a low torque to inertia ratio. Low power density and a low torque to inertia ratio. No idea what that means, but okay. To summarize, stepper motors are good when you need an inexpensive, easy to control solution and when efficiency and high torque at high speed are not necessary. Okay? Basically 3D printing, right? To learn more about pick the right brush. Okay, so and the difference between stepper, brushed, and brushless motors, click here. Okay, I've seen, for example, I've seen Scott talking about brush and brushless motor, I think for the dragster. So maybe the dragster is a different question, right? Maybe they need a high torque at high speed for the dragster. Maybe that's why they don't use steppers, because they don't care about accuracy. They care about speed and torque for the dragster. And maybe brush are better, maybe these one brush thing, maybe are better at this than the stepper. Stepper motor use and application. Yeah, 3D printer is here. So printer, cameras, engraving machine, 3D printer, robot arm, ATM machine. Okay, good. Perfect. 3D printer use servers type motors. 2D printer, it doesn't belong on this list. Oh, okay. Okay. So that was a pretty good learning. Let's do a quick water break. Oh, it's been 2 hours? Wow, we spent 2 hours on stepper motors. Just make I'm lost. Really? Did I went too fast? I tried to I mean, I don't even need to try because I'm usually slow at understanding. So usually people are usually following along. But yeah, if you're lost, maybe I went a bit too fast at some of the steps. Okay, so how are we going to so let me try to summarize. So I guess it's stepper motor and driver. I think they kind of need to go a bit together. I've taken apart many 2D printer and I have yet to find a stepper inside. I don't know. Maybe it was a mistake. Is there a high failure rate for these? What drives the aftermarket? What? Is there a high failure rate for this? For the stepper motor? Well, they say it's pretty reliable. That's one of the advantage. One of the advantage is the long lifespan. So I don't know. I guess no. Sorry, David. I'm not sure I understand your question. Okay, so how are we going to structure that? Stepper motors. What define stepper motors? Now that we understand all of this. So phase number. Okay, phase number. We know what it is. Rated voltage. So the voltage will. So if the intensity was defining the torque, what does the voltage? The voltage is what's. Why do we need a voltage then? Let me check. What is the so voltage is resistance times this, right? Something like this. Let me think. I'm trying to understand why do we care about voltage? Because if we want more torque, then we need more intensity. But there is a relationship between voltage and intensity, right? V over I. So if you have a high voltage, you can have a high. So if let's say I don't care about the voltage. Let's say I have 1 volt, and I have a very high intensity. Then my resistance will be very low. But it's very hard to make a very low resistance in a stepper motor, right? With all the wiring and stuff. So R will be high. So if you still want a high intensity, then you have to increase your voltage. Because the R, it's hard to make a low R because of all the coils. So if we want a higher torque, we need a higher I. And if we want a higher I and keep the same R, then we need a higher V. And that's the reason why the V is important. Okay, got it. Makes sense. So the rated voltage in this case is 2.8, and the rated current is 1.68 per phase. Okay, and we kind of calculate the resistance. So basically, if I do this divided by this, I should have this, right? I don't have my phone here. Let me just check. If we do 2.8, is it V divided by I? 2.8 divided by 1.68. 2.8 divided by 1.68. 1.666. So, and that should be basically 1.65. Okay, makes sense. Okay, so that's the resistance. Okay, and that's the resistance at 20 degrees. And the inductance is the thing that goes with the coil. I think it's something related to the coil, like how good how powerful the coil are. I think it's inductance. Okay, rated coil. Okay, step angle is 0.9. So 0.9. Okay, so that's how. But how? Oh, so 0.9 is the actual step. So from there we can calculate the number of pole pair. So if we do 0.9 degree means, so we have 360. So if we divide 360 by 0.9 divide by 2, we have the number of pole pairs. Okay, so let's do that. So if you have 360 divided by 0.9 divided by 2, so we have 200. We have 200 pole pairs. 200 pole pairs per phase. So in total we have 400 teeth. Okay? No. In total we have 800 teeth, because let me think. Wait, let me think. So it's a 0.9 steps. No. There's 200 pole pairs, but it's not per phase. There's 200 pole pairs in total. So that means there is 100 pole pairs per phase. There is 100 pole pairs per phase. So it means this stepper motor is 100 pole pairs because it's 2 phase. Yes, 360 divided by 0.9. Okay, so that gives 400. So there is 400 position, and then it goes from one phase to the other phase. So there is 200 position for each phase. I lost it. Let me do it again. 360 degree. Divide by 0.9. So that's the number of steps. Oh, so I don't need to divide by 2. No. It's not the number of steps. It's the number of... Wait. 0.9. 360 divided by 0.9. 0.9 is... Yeah, it is the number of steps. So yeah, it will give me... No, sorry. It will give me... So that gives me 400 steps to make one turn. Is that correct? 360 divided by 0.9. Yeah. So it gives me 400 steps. If I have 400 steps, it means there is half of the step are for one phase, half of the step is for the other phase. There is 200 steps per phase. Steps per phase. And one step is basically one alignment. So it's one pole pair. It's one pole pair. So there is 200 pole pairs per phase. So that means there's 400 teeth. There is 800 teeth. That means there is 800 teeth. Right? teeth. We pair them together. 400, 200 per pair. Am I correct? Because I'm just imagining. Can you imagine 800 teeth on this? On something that is like this? Like it means there is a teeth every... every foot. Wait, no, but why the step? The step is 0.9, so there is 400 steps. No, why I multiply by 2? There is 400 steps, there is 400 teeth. There is no multiplying. Why am I multiplying? 400 steps, 400 teeth. And then 200 steps per phase, 200. Yeah, 400 teeth. Well, I don't know why I'm multiplying by 2. Tooth, I guess. 400 tooth. Yeah, okay. Yeah, makes sense. Yeah, 400 point. Okay, sorry, let me catch up a little bit. Just curious why they are aftermarket stepper motors if not due to failure. No idea. I don't know why there is an aftermarket for stepper motors. Steppers are current driver. What matters is the amperage running on the coil. That voltage on the data sheet is the maximum voltage you can apply to a coil before burning it due to the resistance. Steppers are current driven. What matters is the amperage running on the coils. That voltage is in the data sheet is the maximum voltage you can apply to a coil before burning it due to the resistance. But it's kind of all linked, right? Voltage, resistance, and amperage, it's all linked, right? Also, self-builders need a source. Thank you for being awesome, Cannabikes. That resistant AC, not DC. But close. Coil will simulate voltage, so inductive should be result of this. Okay. Not exactly. The phases are offset, and one side has one more than the other. The phases are offset, and one side has more than the other. There isn't one tooth for every step. Enjoy your sushi and ramen, sideline. There isn't a tooth for every step. Have a great night, Sideline. That is why 1.8 degree steppers are fine for most 3D printed. I resist you more than you need. Sorry, Alex, I don't understand why there is no one. Oh no, sorry, 400 teeth. Tooth is singular, right? One tooth per step. My understanding is that each step is a position that the motor can move to. Yeah, so there should be one teeth per step, right? No teeth. But then what's the step angle? So what's a step then? I thought a step was what we talked about, right? Like here, there is 2 steps, right? 1, 2, 4. 1, 2, 3, 4 steps. And here 1, 2, 3, 4, 5, 6 steps. 6 steps, 6 teeth. 4 steps, 4 teeth. Not sure why we're getting ramen. It's 102 outside. 102 Fahrenheit. I guess it's on the hot side. I don't know, but ramen is delicious. Ramen is delicious. My first ramen was in Japan. It was delicious. Hi, Matt German. Because of the offset between phases, they don't need a tooth per step. Don't be sorry, Matt. Hi, OneRaz. Because of the offset between phases, they don't need a tooth per step. How? If there is no, like, okay, let me build my my stepper motor. Otherwise, I don't understand how can you have hang in middle on peak? But you cannot hang in the middle. How can you hang in the middle? The steppers do something clever to get all this position. Yeah, but what does it do? That's the thing, right? How can it? It has to align with a pole pair, right? Thank you for being awesome. OneRaz. Did I just say that? Or maybe Google a disassembly of a NEMA stepper motor. Okay. NEMA stepper motor. I thought that would be the easy part, but for me, one step is one pole pair, but apparently not. So I guess we have to. So what's the definition of a step then? Like when they say when they say here 0.9 degree for a step angle, and what do they mean? What do they mean by that? I thought that what they mean is like, you know, the different teeth, you know, how. Whoa, I had a complete blackout. Sorry, I don't know why. Am I back? Maybe maybe we our brain is boiling. My brain is boiling at this point. Okay, I'm back. Okay, sorry for that. We overloaded the stream with knowledge. Well, mainly in your knowledge than mine, but yeah, so that's the thing I don't understand, Alex. why, let's say it doesn't have to align with pole pairs, right? Let's say we are talking about micro stepping, but then what's the point? What's the point for a stepper motor manufacturer to give the step angle if he can be anywhere in between, depending on the micro step, the driver you are giving? Because micro step depend on the driver. It doesn't depend on the stepper motor, right? It depends on what driver you're using, or at least that's my understanding. So if they are defining the step as what a driver plus a stepper can achieve, then they need to give what driver they are using. But if it's only to define the stepper motor, then if it can be in between, then I don't. Then it can be 1 million step, right? Or it can be 2 billion step, right? It can be anywhere in between. So that's what I don't understand. So if you look at the diagram with 6 pole, okay, let me check. This one on the stators and 4 poles on the rotors. If you look at the diagram with 6 pole on the stator and 4 poles on the rotor. Oh, so so when you mean when the stator has more, when the rotor has more thingy. Nothing on screen? You're not yeah, my internet is too bad. I am screen sharing, but you're not seeing it. Can you still hear me? Oh, why? Suddenly my internet is completely dropped. Has completely dropped. Yes, okay. Okay, then yeah, my internet is really, really bad. Maybe we'll just I think we scared the steppers away. Yeah, okay, then let's just finish now. Then we'll continue next time. Because you cannot even see my screen share, so you won't be able to see my beautiful PPT. But anyway, maybe today was just a little bit on stepper motors, and then we can do the knowledge organization later. Okay, great. Yeah, that was an introduction, Zombie. Exactly. Okay, great. So, but then you won't be able to see my screen for the giveaway, right? Let me stop sharing, and then share again, maybe. How about now? Can you see anything? VFA optimization model, what is that? Yeah, you can see. Okay, great. So let's just finish with our giveaway. Thank you for being awesome, Creatrix. Thank you for being awesome, everyone. A lot of people are awesome. Yak Drugs. Great. I see the screen say Nightcore 1. You have an interesting screen, Nightcore. This will be a dual phase stream. A dual phase stream? Anyway, I learned a lot today. I mean, some of it I knew it already, but now I know it in a better way, like in a more structured way, in a more detailed way, I guess. So I'm hoping you have at least learned one thing today. Again, like I say, I did learn a lot. There is still a lot to learn, right? But let's continue that next time. I'm not the only awesome. I'm good looking. I'm not only awesome. I'm good looking. I should have another stream. with another giveaway. I'm good looking. Part 1, part 2, duel, more jokes. Oh, okay, got it. Okay, are you guys ready for 3 winners of today? 71 viewers, 54 entries. A lot of people fell asleep. Only, okay, 54, 73 viewers. Okay, I guess we'll just draw now. Thank you, Velasco. And our first winner of today learning live stream is Traxman. Congratulations, Traxman. I think you just participated to the TikTok game, right? I saw your entry. Traxman, please. Oh, actually, my brain is really boiling. I have a small headache. I promise, I have a small headache. I think I love this type of stream. If I have a small headache, it means it was a good stream. It means we dived deep enough. I mean, we could have gone. We haven't dived into the driver much. It was pretty much on the stepper, which I guess is slightly easier than when we will dive into the drivers. But I think the drivers will be interesting as well. Will be very interesting. Maybe we can do that in the next live stream. I think it will be interesting. I'm very bad at hardware, so it's good learning for everyone. Okay, so no Traxman, right? No Traxman. I don't think so. No Traxman. Okay, so let's draw someone else. Time to Womp. What is Womp? Womp. To strike with a sharp noise or thumb. To strike with a sharp noise. Interesting. Okay. Oh, who was the winner? Yeah, Krista. Sorry, I changed the screen. Krista from YouTube. Congratulations. Are you here? Was it Paisley's? No, I think it's Krista from YouTube. YouTube game. The butterfly. Congratulations, Krista. Are you there? None of the winners are here today. WAMP is a LM thing to clear AFK people. I didn't understand any of the stream. It's okay, Krista. At least you were there and you're going away with 3 spools of polymetric filament. I do my best to make everything as easy as possible to understand, but you know, it's hard to get focused for 2 hours. I mean, I literally didn't see the time. I didn't know it was 2 hours. We were talking about stepper motors. So it is hard. It is hard to focus during 2 hours. That might be the reason why I have a small headache, right? Okay, so Krista, congratulations. So you are our first winner. So you are on YouTube, so you cannot see the comments. So let me just send you my email. Just reach out to me. If you are not on our Discord, you can reach out to me on our Discord as well. But otherwise, just reach out to me via this email. I will send you a link. We could talk about stepper motors for days. Yeah, of course. We can always dive deeper and deeper and deeper and deeper. 3DHP, how's everything? Our second winner is Aaron Burley from Twitch. Aaron Burley, congratulations. Aaron Bailey, are you there? You're very welcome, Krista. Aaron Burley. Aaron Bailey once. Aaron Bailey twice. Aaron Bailey 3 times. Not there. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Sorry, Aaron Barely. Draw again. And our new second winner, right? Second winner, I think, is Bang Scene Function. Yeah, I need Nervous Pajamas. I think Nervous Pajama is here. Nervous Pajama. Yeah, congratulations, Nervous Pajama. And so this is the second or the third one? So we had Krista. That was the second, right? So I still need to do one time, right? The second one, okay. Because there's many people. Okay, got it. That's that patch. That's the first one. Okay, let's draw again for the last one. Yeah, congratulations again, Nervous Pajama. And our last winner of today is Sheldon B 2020. Sheldon B, are you here? Sheldon B, with this cute. What is this? Is that a Chihuahua? Is this a Chihuahua? Sheldon! Congratulations, Sheldon. Builders Mark just bang contact for you. You can reach out to me for your free spool. Congratulations. Yes, it is a Chihuahua. Okay, great. Very nice. So, I have an image of an internal structure of a stepper. I will post it on Discord. Yeah, thank you so much, Alex. Thank you so much. Oh, okay, got it, Sheldon. Sorry to hear that. Very beautiful dog, by the way. Very beautiful. Okay, let me find someone. So last time you said that you didn't like when we rate someone outside, like the recommended. So from now we will rate people that we know, right? And oh, the 3 even is finally live at the same time as me. Let me see. Is he live? Yeah, he is. The 3 even. I think he is back to his old schedule of live streaming, or at least I see him live streaming much more often than before. So let's go and say hi. As a Mexican, I approve. He's a Chihuahua. Oh, Chihuahua is Mexican? I had no idea. Anyway, thanks again, everyone, for joining today's live stream. I hope you had some good learning. I think we should do that more often. I think the Friday before we did Print Busters, we should have something similar where we just dive into something and we just learn, right? We just like stepper motors, we just learn about it. Nozzle, we just learn about it. Extruder, we just learn about it. Whatever, we just learn about it, and then we just dive into it, and then we slowly build our knowledge. I think we should do that more often. I really enjoy this type of live stream. I've been printing Q4 images of printables and bought 30. It's amazing. We'll do a video soon and plug Polymaker. Thank you so much, 3DHP. Looking forward to it. Don't forget to put it in our Discord in the awesome content once you have the video. Dive into Details series. Oh, good name. Dive into Details. Dive into Details show. The DID show. Yeah. It's. Let's continue thinking some ideas. Dive into Details is not bad. I'm thinking if we can do some kind of word. Anyway, let's still think about it. So thanks again, and I will see you in the next one.